thing about today's mini lesson is that you're going to focus on one way to look at multiplication. So just say one way.
One way
to look at multiplication.
To look at multiplication.
And the way to do that is through the array model. Okay. So this is the definition of an array. To set out for display or use, place in an ordinary arrangement. Ugh. Does that sound like anything that kind of makes sense?
No.
Okay. I mean, maybe it did to you, but it really didn't help me much. So basically, what does that mean? What does it look like? I want you to look at real life examples of arrays. Anybody know what this is right here?
Solar system?
Oh, she is extremely close. Very good. Solar, keep that word in there.
Solar lights. Solar lights.
Right, this is a setup of a way that you can get solar energy. So you may see buildings that have this array model in order to get solar energy, so they don't have to plug everything up and take energy from big power plants. They can plug it up and the power comes from the solar energy. I know when you guys are listening to some really good music and it's really, really loud.
Speaker.
What? Say that one.
Speaker.
Very good. Speakers are set up in an array. They're organized into a certain type of structure. So we see that these are organized. Or you tell me, are they organized?
Yes.
Okay, real life example of an array. Organized?
Yes.
Is everything all over the place?
No.
Okay, set up right there. Good. Everybody can say it out loud.
A building.
A building. What is it that makes us an array?
The window.
Say it. It's okay.
The window.
Very good. The organization of the windows. These are real life arrays. There's nothing that I want you guys to learn in school that you can't make a connection with on the outside world. Because everything works together. The things that we see in real life, the things that we see in books, the things that we see on movies, here on television, everything comes together to be a part of your world. So just know that when we're looking at arrays today, they're actually found in real life. Does that make sense?
Yes.
Okay, let's go on to the next one. Now, the focus of our mini lesson is the array model. I'm going to talk you through this. And the essence of talking through it is because it's a long lesson or short lesson?
No. Short.
Short lesson. So I'm going to take you step by step. Every now and then I may ask for your help. But I really want to explain to you where everything is coming from. Now, the problem that this array model shows is 13 times 12. Everybody, repeat that after me.
13 times 12.
Or 13 multiplied by 12. Let's say that.
13 multiplied by 12.
Very good job, boys and girls. We see that right here represents how many?
100.
100. Very good. I want you to come up and I want you to hold this block right over there. Do that for me. 100. You just hold it right there. You can actually get to the side because we're going to have people to show us exactly what this model looks like. So 100 is represented right here because by the time you finish multiplying, you are going to be in the hundreds place value. Am I correct?
Yes.
All right, with your answer.
Yeah.
Now, 3. I see 3 groups of 10. I see 2 in the ones place that stands for. I'm trying to work this out. Where do they get 1, 1, 2, 3? Where did this come from?
10 blocks.
The 10 blocks. The 3 that we have right here and the 13. These are going to represent our 3 groups of how many? 10. Very good. I'm going to hand you 3. And I would like you to stand on the right-hand side of them. Now, where did we get these 2 groups of 10 from? Ladder. Hold on for a moment. I think our base 10. Oh, okay. And,
We got from them.
okay. I was just making sure because they were talking a little bit. I want to make sure they knew where they're supposed to go. Where are these coming from?
100.
You were sharing. Talk more through it.
110. The 10 represent the 10 and the 12. The 10 represents that 10.
We are pulling
The
2 groups of
12.
10 from this area right here. He has
Because
them.
the 2 equals the 2.
So we have 2 groups of 10. I want you to come up here and represent that. Now, we've identified where we've gotten that from. Where, no, just get over there. We represented where we've gotten those from. But I have a space right here. I have a space right here that is unaccounted for. How many ones do we have right there?
6.
We have 6. And I'm breaking this down very simplistic. And I say that to say, I want you to know where each one of these numbers came from. Let's have, in the back white shirt, come up and hold our, how many ones do we have?
6.
All right, come up and hold it. Quickly. Very good. So, where did this come from?
Our 100.
All right. Where did the 50 come from?
Our 10.
Our 10s. Let's count the 10s up.
1, 2, 3, 4, 50.
50. Very good. How many groups of ones do we have?
6.
Very good. Point to where that group of ones is located. Very good. 100 plus 50 plus 6. Oops, go back for me, please. It's fine. It's okay.
It looks hard.
100 plus... You're still touching it. Don't touch it. Okay.
Not funny.
If you don't have to respond, 100 plus 50 plus 6 equals how much?
156.
156. What's 13 times 12?
156.
Do you see the correlation or the similarities between how you're able to do an array model and how you're able to break it down over here?
Yes.
Very good. Let's count and see if our array model matches exactly what we have here. Do we have them in order? Yes. So let's begin counting.
100. 10.
You put it 100. 100. 156. Did we represent the same thing on our array model that we had using the base?
Yes.
All right, please give your participants a hand. Now this is broken down even more for you, and I hope you can see it. This is a different problem, 14 times 16. I like to show boys and girls the array model not only when the numbers are going this way, but also that way, because we know that with multiplication, does it make a difference? Does it? I can put 14 times 16 and 16 times 14. Does that make a difference?
No, it'll be community.
It will still be using the commuting property. Excellent job. So we are going to look at how this problem was broken down, and we are going to apply what we saw with the other model to the same type of problem. We know that the 100s came from what?
10.
So 100 times 100 is what?
10.
Very good. Where did you get your 4 from? Point to it.
10.
Very good. 4 times 10 is what?
40.
40. Excellent job. 10 times 6 is what?
60.
There you have your 6 tens represented. And now you have your 4 times 6. And that creates your 1. That is what? 24. Very good. This is a different type of way at looking at multiplication. What model is it called?
Community property. Array.
The array model. Say that again.
Array model.
Excellent job, boys and girls. I want you to see where all of the numbers in the array model are pulled from, how they're represented, and how you're able to show that using the array model. Now, I'm going to take you to Learn Zillion, which Ms. Durham can use when you guys are at your math center. Really cool website that gives you quick videos on exactly what you're learning about. And I pulled a video that focused on the array model. Do you like that?
Yes.
5-minute video. So I probably taught for about how long, Ms. Durham?
10 minutes and 30 seconds.
10 minutes. So that's my mini lesson. I leave this open so that you guys can have something to take your lesson on to the whole group. And then if you have anything breakout that you like to do, like an independent practice or math center, after the video, that'll be a great time to do it. But today we focused on what method of multiplication? The what model?
Array model.
All right, boys and girls. You did an excellent job. I want you to pay close attention so that you'll be able to get even more tips and tools about the array model. And thank you for continuing to stay focused the entire time.